Python regular expression operations re.sub n pattern dot replacement dot string dot count is equal to 0 comma sorry pattern comma replacement comma string comma count is equal to 0 comma flags is equal to 0. Perform the same operation as substitute but return a tuple new string comma number of substitutions made. Re.escape pattern escape special characters in pattern. This is useful if you want to match an arbitrary literal string that may have regular expression meta characters in it. For example, print re.escape https colon dot slash slash www.python.org print re.escape. For example, import re print re.escape will print this one. org. Okay, legal underscore cats is equal to string dot ascii lowercase plus string dot digits plus this one print percentage s percentage okay string import this name, so we have to import string. Now if I run it, so it will print like this one. We'll escape this one. Okay, got it. Operators is equal to this one print operators. Operators is equal to this one or dot join map re dot escape comma re dot escape comma sorted operators reverse iterable sorted operators reverse is equal to true. Okay, it also separated this. This function must not be used for the replacement string in sub and sub n. Only backslashes should be escaped. For example, digits digits is equal to this one regular expression d plus sample is equal to user being sandmail 0 errors 12 warnings. So re dot substitute digit re comma digits re dot replace this one. Sample it will print. Re dot purge clear the regular expression cache. Okay, then perform re dot purge clear the regular expression cache. Exceptions, regular expressions are cached, so we have to clear the cache. Okay, exceptions. Exception re dot error message comma pattern is equal to none position is equal. Exception raised when a string passed to one of the functions here is not a valid regular expression. For example, It might contain unmatched parentheses or when some other error occurs during compilation or matching. It is never an error if a string contains no match for a pattern. The error instance has the following additional attributes: message, the unformatted error message; pattern, the regular expression pattern; post, the index in pattern where compilation failed may be none; line number, the line corresponding to position may be none; column number, the column corresponding to position may be none. Regular expression objects. Class re.pattern. Compile the regular expression object returned by re.compile. Pattern.search. String, comma, position, comma, and position. Scans through string looking for the first location where this regular expression produces a match and return a corresponding match object. Return none if no position in the string matches the pattern. Note that this is different from finding a zero length match at some point in the string. The optional second parameter pose gives an index in the string where the search is to start. It defaults to 0. This is not completely equivalent to slicing the string. The caret pattern character matches at the real image beginning of the string and at positions just after a new line, but not necessarily at the index where the search is to start. The optional parameter and position limits how far the string will be searched. It will be as if the string is position characters long. So only the characters from position to end position minus 1 will be searched for a match. If end position is less than position, no match will be found. Otherwise, if Rx is compiled, regular expression object rx.search string, comma 0 to 50 is equivalent to rx.search string 50, comma 0. Pattern re.compile d, pattern.search dog. re.compile read, pattern.search result is equal to pattern print result. Okay, what I need to do: span 0 to match dot d, pattern dot search dog 1 and pattern dot search 1. Result is equal to pattern dot search print result. No match. Pattern dot match string position and position. If 0 or more characters at the beginning of a string match this regular expression, return a corresponding match. Return none if the string does not match the pattern. Note that this is different from a zero length match. The optional position and end position parameters have the same meaning as for the search method. Pattern re.compile o, result is equal to this. Oh, same program. Result is equal to this. Print result. Okay. 1 to 2 match is equal to O. This is none. DOG. Not at the start of dog, and this is start of dog. Okay. If you want to locate a match anywhere in a string, use search instead of search versus match. Pattern dot full match string, position and position. If the whole is string, matches this regular expression, return a corresponding match. Return none if the string does not match the pattern. Note that this is a different from a zero length match. The option position and end position parameters have the same meaning as for search method. Match. Here we can see OGH and dog, full match OGRS, no match SZ, O is not at the start of dog, and OGRE, no match as not the full string matches, and pattern dot full match DOGGIE. So 1 to 3 OGG matches within given limits 1 to 3, 1 to 3, 1 to 3. Okay. Pattern dot split string comma max split is equal to 0, identical to split function using the compiled pattern. Pattern dot find all string comma position comma end position, similar to find all function using the compiled pattern, but also accepts optional position and end position parameter that limit the search region like search. Pattern dot find iterator string comma position comma end position, similar to the find iterator function using the compiled pattern, but also accepts optional position and end position parameter that limit the search region like for search. Pattern dot sub replacement comma string comma count 0, identical to sub function using the compiled pattern. Pattern dot sub and replacement comma string comma count is equal to 0, identical to sub and function using the compiled pattern. Pattern dot flags, the regular expression matching flags. This is a combination of the flags given to compile any question mark dot 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 inline flags in the pattern, and implicit flags such as Unicode if the pattern is Unicode string. Pattern dot groups, the number of capturing groups in the pattern. Pattern dot group index, a dictionary mapping any symbolic group names defined by question mark PID to group numbers. The dictionary is empty if no symbolic groups were used in the pattern. Pattern dot pattern, the pattern string from which the pattern object was compiled. Match objects. Match objects always have a boolean value of true. Since match and search return none when there is no match, you can test whether there was a match with a simple if statement. Match is equal to rd dot search pattern string if match process match. Okay. Class re dot match, match object returned by successful matches and searches. Match dot expand template, return the string obtained by doing backslash substitution on the template string. String template as done by sub method. Escapes such as backslash n are converted to the appropriate characters, and numeric back references backslash n comma backslash 2 and named back references backslash g1 backslash g name are replaced by the contents of the corresponding group. Match dot group, group 1 sub returns one or more subgroups of the match. If there is a single argument, the result is a single string. If there are multiple arguments, the result is a tuple with one item per argument. Without arguments, group 1 defaults to 0. The whole match is returned. If a group n argument is 0, the corresponding return value is the entire matching string. If it is in the inclusive range 1 to 99, it is a string matching the corresponding parenthesized group. If a group number is negative or larger than the number of groups defined in the pattern, an index error exception is raised. If a group is contained in a part of the pattern that did not match, the corresponding result is none. If a group is contained in a part of the pattern that matched multiple times, the last match is returned. M is equal to re dot match, or W plus Isaac Newton physicist. M dot group 0 Isaac Newton entire match, and M dot group 1 Isaac entire match. First parenthesis the subgroup Isaac, M dot group 2 Newton, and M dot group 1 to 2 Isaac Newton. Okay. If the regular expression, let me run the program. Result is equal to group print result, then result is equal to M dot group 1 and print result, and then result is equal to M dot group 1 in the range 2 and print result. So let's see. Okay, and now let me print result count of result, length of result. Let's see if it gives error or not. Is equal to 2 ra dot match if there are. Okay, this is group 1, this is group 2. Simple. Group 1, group 2. And if I say comma backslash w plus okay, this time also 2. Comma. Comma. Okay, 1, 2, 3. So these are group 1, 2, 3. Okay. If the regular expression uses the question mark p name syntax, the group and arguments may also be strings identifying groups by their group name. If a string argument is not used as a group name in the pattern, an index error exception is raised. A moderately complicated example, this one. For example, this one. Unresolved name. Why? Oh man. Array dot match and print. This is named group first name and named group print m dot group named group last underscore name. So re dot match. Okay, this one was from the previous example. So re dot match p first name w plus and last name w plus. First name last name. Okay, correct. This is the named group example, right? Named groups can also be referred to by their index m group 1 and 2, right? This is same as like 1 1 and same as 2. Output it would be same. If a group matches multiple times, only the last match is accessible. This match dot dot matches 3 times. Okay, a1 a1 b2 c3, but return only the last match. Okay, m dot group 1 print return only the last match. Correct. c3. Match dot get item g. This is identical to m dot group g. This allows easier access to an individual group from a match. M is equal to re dot match this m0 Isaac Newton, m1 Isaac and m2 Newton. So named groups are supported as well. M is equal to re dot match first name last name. This one same way. Match dot groups default is equal to none. Return a tuple containing all the subgroups of the match from 1 up to however many groups are in the pattern. The default argument is used for groups that did not participate in the match. It defaults to none. For example, m dot re dot match r d plus dot d plus, then m dot groups is equal to this one tuple. If we make the decimal place and everything after it optional, not all groups might participate in the match. These groups will default to none unless the default argument is given. Re dot match this one, this doesn't match, so m dot groups is equal to 24 none. Right, and m dot groups 0 is equal to, now the second group defaults to 0, right? Match dot group dict, return a dictionary containing all the named subgroups of the match keyed by the subgroup name. The default argument is used for groups that did not participate in the match. It defaults to none. For example, re dot match first name last name. m dot group dict is equal to first name colon last name, this one. Okay, match dot start match dot end. return the indices of the Return the indices of the start and end of the substring matched by group. Group defaults to 0, meaning the whole matched substring. Return -1 if group exists but did not contribute to the match. For a match object M and a group G that did contribute to the match, the substring matched by group G equivalent to M dot group G is M dot string M dot start colon M dot end G. Note that M dot start group will equal to M dot end group if group matched a full string, null string. For example, after M is equal to re dot search b c comma cba, M dot start 0 is 1, M dot end is equal and 0 is 2. M dot start 1 and M dot end 1 are both 2, and M dot start 2 raises an index error. An example that will remove underscore this from email address. Email is equal to let's see the example. Print email is equal to Tony at the rate tiremove underscore this girl dot net. re dot search remove underscore this comma email. Print m dot groups and bracket no match. M dot start comma M dot end. Seven 18 Tony at the red tiger dot net. Great. Match dot span group. List of group. For a match M, return the two tuple M dot start group M dot end group. Note that if group did not contribute to the match, this is -1 group defaults to 0 the entire match. Match dot position. The value of position which was passed to the search or match method of regular expression object. This is the index into the string at which the regular expression engine started looking for a match. Match dot end position. The value of end position which was passed to the search or match of method of regular. This is the index into the string beyond which the regular expression engine will not go. Match dot last index. The integer index of the last matched capturing group, or none if no group was matched at all. For example, the expressions a b or ab will have the last index is equal to 1 if applied to a string ab, while the expression ab will have the last index is equal to 2 if applied to the same string. Match dot last group. The name of the last matched capturing group, or none if the group didn't have a name if no group was matched at all. Match dot re. The regular expression object whose match or search method produces this match instance. For example, let's print m dot re. It will print remove this. Okay, Match dot string, string passed to match or search. Match dot string, string passed to Tony at the rate. Okay. Regular expression examples. Checking for a pair. If this if this example, we will use the following helper function to display match objects a little more gracefully. Diff display match. If match is none, return none. Return match percentage r groups is equal to percentage r. Match dot group, match dot groups. Okay, let's copy this. And then suppose you are writing a poker program where a program player's hand is represented as a 5 character string with each character representing a card: A for ace, K for king, Q for queen, J for jack, T for 10, and 2 through 9 representing the card with the value. To see if a given string is a valid hand, one could do the following. Valid is equal to re dot compile start start a a 2 to 9 t j g q, then 5 5 end. So display match, result is equal to display match, print result. Display match valid dot match AKT5Q. This is valid. Then display match invalid. E is not the last hand 7 to 7 AK contained a pair or two of the same valued cards. To match this with a regular expression, one could use back references as such. Pair of sevens. Dot star dot dot star. To find out what card the pair consists of, one could use the group method of the match object in the following manner. Pair is equal to re dot compile this one backslash 1. Pair is equal to pair dot match 717 AK groups 1 7. Error because re dot match returns none, which doesn't have a group method. Pair dot match 718 AK group 1 trace back. Simulating scanf. Python does not currently have a equivalent to scanf. Regular expressions are generally more powerful, though also more verbose, than scanf formatting for strings. The table below offers some more or less equivalent mappings between scanf format tokens and regular expression. Scanf token regular expression percentage %c dot percentage 5c dot 5 percentage d minus plus question mark d plus percentage e percentage capital E percentage f percentage g minus plus question mark d plus then dot or any number of digit question mark dot or d plus, then followed by small e or capital E, plus minus, uh, and then digit, percentage I minus plus this one. Okay, you can go through this. And then to extract the file name and numbers from a string like user base meanness and man zero errors for warnings, you would use a scanf format like this: percentage s hyphen percentage d errors, percentage d warnings. The equivalent regular expression would be um, backslash s plus hyphen backslash d plus errors comma d plus warnings. Search versus match. Python offers different primitive operations based on regular expression. re.match checks for a match only at the beginning of the string. re.search checks for a match anywhere in the string. This is what Perl does by default. re.fullMatch checks for entire string to be matched. For example, re.match C A B C D E F no match. re.search C A B C D E F match. re.match object span 2 to 3 2 to 3 match is equal to C. re dot full match P dot star and Python match. re dot match object span is equal to 0 to 6 0 to 6 0 1 2 3 4 5 and 6. Match is equal to Python re dot full match r dot star and Python no match. Why? Yep. Regular expressions beginning with caret can be used with search to restrict the match at the beginning of the string. So re.match, this one no match, re.search start and start. So match and no match. Okay. Note, however, that a multi-line mode match only matches at the beginning of the string, whereas using search with a regular expression beginning with this will match at the beginning of each line. re.match x, no match. re.search x, there is a match, and match at 4 5 0 1 2 3 4 and 5. Making a phone book. Split splits a string into a list delimited by passed pattern. The method is invaluable for converting textual data into data structures that can be easily read and modified by Python, as demonstrated in the following example that creates a book. First, here is the input. Normally it may come from a file. Here we are using triple quoted string syntax. Text is equal to cross format this one and string more this one. Okay, the entries are separated by one or more new lines. Now we convert the string into a list with each non-empty line having its own entry. Entries is equal to re.split new line plus text. Entries is equal to this one. Finally, split each entry into a list with first name, last name, telephone number and address. We use max split parameter of split because of the address has spaces. Our splitting pattern in it re.split colon question mark space entry and 3 for entry in entries. So this would be the list. The colon question mark pattern matches the colon after the last name so that it does not occur in the result list. With a max split of 4, we could separate the house number from the street name. re.split entry 4 in and entry in entries, so we can split house number. Text mungi sub replaces every occurrence of a pattern with a string or the result of a function. This example demonstrates using sub with a function to mung text or randomize the order of all the characters in each word of a sequence except for the first and last character. Diff rep l inner word is equal to list m group to random dot shuffle Inner word return m dot group 1 plus join inner word plus m group 3. Text professor Abdulmak, please report your absences promptly with WW plus W repel text. Professor, this okay. Okay. Finding all adverbs, find all matches, all occurrences of a pattern, not just the first one as search does. For example, if a writer wanted to find all the adverbs in some text, they might use find all in the following manner. Text is equal to this one and find all W plus ly this text carefully, quickly. Finding all adverbs and their positions. If one wants more information about all matches of a pattern, then the match text find iteration and is useful, and it provides match object instead of strings. Continuing with the previous example, if a writer wanted to find all of the adverbs and their positions in some text, they would use find iterator following one. This was the text for m in re dot find iterator, or this one print percentage 02 percentage 02d colon percentage s m dot start m dot end m dot group 0. Okay. Okay, row string notation. Row string notation R tags keeps regular expressions same. Without it, every backslash in a regular expression would have to be prefixed with another one to escape it. For example, the two following lines of code are functionally identical. re.match are w dot 1 w f f re.match of 0 to f f re.match. Okay. When one wants to you match a literal backslash, it must be escaped in the regular expression. With row string notation, this means r backslash backslash. Without row string notation, one must use backslash 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 backslash, making the following lines of code functionally identical. Re dot match re this match this one, re dot match this one. Okay, writing a tokenizer. A tokenizer or scanner analyzes a string to categorize groups of characters. This is a useful first step in writing a compiler or interpreter. The text categories are specified with regular expression. The technique is to combine those into a single master regular expression and to loop over successive matches. From typing import named tuple, import re, class token named tuple, type str, value str, line integer, column. Define tokenized code keywords is equal to if, then, and if, for, next, go sub, return. Tokenized specification is equal to number is equal to this, assign is equal to this, and this. All the regular expressions for request respective tokens. Token underscore regular expression dot join this 1% pair or pair in specification. Line number line start for mo in re dot find token kind is equal to last group value is equal to group column is equal to mo dot start minus line start, and if kind is equal to number value is equal to float value if dot in value else integer value else if kind is equal to id and value in keywords kind is equal to value else if kind is equal to new line start is equal to mo dot end line number is plus is equal to 1 continue else if kind is equal to skip continue else if kind is equal to mismatch raise runtime error f value point exclamation r unexpected on line number yield token kind value line number column number statements is equal to if quantity then total number this for token in tokenize statements print. Okay, let's copy the program and paste over here, right, and run it. So these are the tokens. Output is this Thank you.